Hello, and welcome back to Humanity First. Today I wanted to talk about a technical breakthrough in the field of artificial intelligence that happened fairly recently. I wanted to bring this up um, a few episodes ago, but it kept getting outcompeted by other subjects that we wanted to discuss. But today's the day, and so we'll finally talk about it. So, this breakthrough was recently announced in a publication. I think it's like 2 weeks ago now. Um, So it came out in a publication by a group of MIT researchers. So this is an academic group that is publishing this work, and that's exactly why we're hearing about it, because a lot of the research that's happening in this field is happening at these large companies that are all competing with each other, and so they're not really publishing their work. But for this particular breakthrough, it was published. It was a group of academics that came up with it, so it is published. And the paper is titled Recursive Language Models, and I'll link it in the description. And we'll talk firstly about the technical aspect of the problem, and then we'll talk a bit about the significance. So, first, the technical aspect. The paper is meant to tackle an issue that language models face that actually is also an issue for other applications of deep learning, and it has to do with what's colloquially known as context rot. And you might have experienced this yourself if you use like ChatGPT or the alternatives out there, the chatbots. You might notice that as you talk in one conversation more and more with the model, initially the model's performance improves. So as you give it more context about the problem or about your particular situation that you're discussing, the model improves its performance. It gets better at giving you the type of answers that you want, at understanding and making connections with previous things that you have told it. But at a certain point, as your conversation gets longer and longer and longer, you'll notice a marked decrease in the performance of the model. And that's exactly what is called context rot. The context that you're feeding, as the previous conversation that you're feeding into the model to generate the outputs, is getting longer and longer and longer. And the longer the context, the worse the model becomes at using the context effectively to answer questions, to make connections. So people are really interested right now in solving this problem for two reasons. First, to make a better chatbot. You want to get a chatbot that will engage more with the customer, that will form deeper connections or relationships with the customer. You want a chatbot that won't forget previous conversations, that isn't limited in this way, that won't see this decline in performance. So it will go a long way to making these chatbots in a way more human-like, that they can retain information for long periods of time about you. And so that the user doesn't need to re-explain the whole situation every time they want to talk to the chatbot. So on the chatbot front, people are really interested in improving and mitigating the effects of context rot. But perhaps more importantly, to solve, if you want to build a model so that you can make it an agentic agent, build an agentic agent on top of the model and have it solve long horizon tasks. So like a week's long programming project, then it really needs to also have very long context to be able to use long context effectively, because it needs to retain a plan over this long period. And it needs to be able to read many, many, many lines of code and keep track of its reasoning for the different things that it added, and use that cleverly to continually generate more and more useful outputs over that long period. So, and ultimately, this is more important because this is where most of the money is. This is essentially the dream of having an automated worker. So people are really, really interested in solving this issue. And that's why this paper got a lot of attention. So the solution, briefly, is essentially, instead of feeding the context indirectly, the previous conversation indirectly, as inputs to the model, so that as inputs to the model to get the next generation, the next generated piece of text. Instead of doing that, and instead of other techniques, so like sometimes people use like auto summarization. So essentially, to prevent the context from getting too big, if it gets beyond a certain size, you call the model to summarize and then use the summary as the context. So instead of those techniques as well, you can think of, you almost have this context in as a kind of like separate file. You can think of it as a separate file. And now you allow the model to search this file as it would search any document, to use tools to interact with its own memory, with its own history. And what they discovered with, like, this is a pretty, I suppose, straightforward suggestion. But what these researchers discovered is that models do a really good job of searching their memory. And that having the model be able to use tools to interact with its own memory dramatically reduces the amount of context rot that you experience. Models turn out to be pretty good at querying their own memory and figuring out what might be the relevant parts to focus on and to read before they answer your next question. So that is the technical aspect. Now, what is the significance of this? I wanted to talk about two things related to significance. So first, the significance that this works. So we discussed before how really having an agent, making a model, an automated agentic worker, that this is like a surface level thing. That as you improve the base model, its ability to use tools improves as well. You need less robust scaffolding if you're using a more powerful model. And that as the model improves, all its tool usage also improves, and its agenticness also automatically improves. Its abilities as an agent, aside from its abilities as just a model that predicts next token, also improves. And this is a great example of that. So models now are capable enough that if you give them the tools to interact with their own memory, they can do a pretty good job at it. They can do such a good job that it somewhat mitigates the effect of context rot. They can figure out what the relevant pieces of their memory probably is and sample that before they give their output. And what they actually showed in the paper as well is that more powerful models are better at applying this technique, which makes sense. Because as the model gets more powerful, it gets better at using tools to interact with its memory. So I said before, when we were talking about the risk of self-improving artificial intelligence, that the model cannot retrain its own, it cannot retrain itself. It cannot, right now, essentially, the weights of the model are actually frozen at time of deployment, at least as far as we know. Maybe there's some refinement that happens after, or actually, certainly there is refinement, fine-tuning that happens afterwards, some cycles of maybe training that happens afterwards to slightly modify the model's weights. But more or less, the weights of the model post-deployment is fixed. But one thing that the model can contribute to improve its own performance is it can build scaffolding for itself. And I remember that in the past I said that, so if you deploy a model, if a model is really powerful and capable, maybe it can write scaffolding to improve its own performance on different tasks. And what this breakthrough shows us, though, what it suggests is that it essentially supports this, and it shows that the scaffolding that can be built will be more and more useful the more capable the base model is. So that jump in performance that models can have by improving their own scaffolding, that jump might be larger than we think as model capabilities continue to improve. So that is the first takeaway from this, is that fact that we are able to do this now, and that by doing this you see these large improvements in the models, shows us, and the model's ability to interact with its own context, shows us that this principle holds true. That as the model gets more powerful, it becomes a better agent, better at tool usage, and that ultimately has that second order effect, where now the scaffolding that you are using, or the tools that you give the model access to, it can use in better and better ways to improve its own performance. So that's the first takeaway. The second takeaway is, what does this breakthrough mean? So I'm certain that all the large companies are now investigating this technique and trying to apply it to their own models. And this breakthrough and a bunch of other breakthroughs that I'm sure are happening behind closed doors are all working to push on this problem of context rot. And ultimately what this will mean is longer model context and a better ability for models to use their context in the future, and a greater ability on the parts of the models to perform long horizon tasks. So this is all coming down the line for sure. And of course, it's the ability of models to power agents that can perform long horizon tasks, that is fully autonomously. That is exactly where the greatest danger is. And that's the world that we're moving towards. And this is just another step in that direction. So expect that future releases of models will continue the trend of models being able to perform longer and longer tasks. Well, okay. So that's pretty much it for today. Thank you very much for listening. I have other subjects that I really wanted to discuss, but I think we're probably out of time today. I'll just keep them for the future discussions. But thank you very much for listening. Happy weekend, and don't forget, winter's coming. All right, take care.